All right, 3-1 triangle inequalities. So the triangle inequality theorem, if you didn't get to do this spaghetti activity in class, states that in order for three sides to form a triangle, the two smaller sides, when you add them together, must be greater than the third side. So if you take the sum of the two smaller sides that has to be greater than the biggest side or the third side. Okay, so let's practice that. And so if we take our two smaller sides here and we add them together, that gives us 17. Well, we ask ourselves, is 17 greater than 10? Yes, that is, so it does form a triangle. Then we have to classify it by its sides. Well, remember, in order to classify it by its sides, we have the three categories. Scalene, which means all sides are different. Isosceles, two sides are the same. And equilateral, all three are the same. So if we look here at these three different sides, 8, 9, and 10, all three are different, making this a scalene triangle. Okay, we go to the next one. We add our two smaller sides together. That gives us 2. We ask ourselves, is 2 greater than 2? No, it's not. So that means these three sides will not form a triangle. And if it doesn't form a triangle, then we can't classify it. Last one here, add the two smaller sides. We get 8. Is 8 greater than 4? Yes, it is. So then we classify, and we can see that all three sides are the same. So it is an equilateral triangle. Okay, so that's how you determine if the three sides will form a triangle. So then let's say, okay, well, if I give you two lengths, 5 and 7, what are the possibilities for those lengths of the third sides? Well, it's going to be a range because remember, it can be, if we take the two smaller sides, it has to be greater than the third side. Well, if 5 and 7 are the smaller sides, then we have to think about that. But if 5 and 7 are the bigger sides, then we have to think about that case. So the way to make this the easiest is to take the two sides given and subtract them, and that gives us 2. Then take the 2 and add them, and that basically gives us our range. So we can say, okay, x has to be greater than 12, has to be less than 12, but it has to be greater than 2. And so your symbols will face the same direction every single time. You take your two numbers and subtract them, and that gives us our first value. Take them and add them, and that gives you your second value, and it will always be set up and look like this. Okay? All right, the next thing that we're going to talk about is how to determine which is the longest side and which is the shortest side, or biggest angle and smallest angle. And so we can use the opposite of what we were given to determine that. So if we were given the angles, we could always figure out who's the longest side because we know that it's going to be opposite the largest angle. Same thing, shortest side will go across the shortest angle. And so if we label these here, we know that A is 120 degrees, B is 40 degrees, and C is 20 degrees. Okay, we can think, okay, well, our biggest angle, if they want us to do it biggest to shortest, our biggest angle is angle A, and across from angle A is side BC. Our next biggest angle is angle B, and if we go across this way, it is side AC is across from that. And then our third side, our smallest side, which is across from angle C, would be side AB or BA, doesn't matter the order. And so this would list it out from greatest to smallest. So our longest side would be BC, and our shortest side would be AB. Another way to look at that is if we know that angle A here, and we were looking for the side that's across from it, we know that point A is not going to be included in the side that's opposite. So you think about the two letters that are not included, and that's BC. Same thing here. If we're looking at angle B, what two letters are we not using? AC. And it works this way every single time. Angle C, we're not using the two letters A and B. So if that's an easier way to figure it out, go for that instead of going across, whatever works best for you. Okay, another question is now let's look at the angles. And so one, they want us to classify the triangle by its sides. So if I look at all three sides are different, making this a scalene triangle. Let's line the sides up from smallest to largest because that's what it's asking for here. So the smallest side is 9, which is side AC. The angle it's across from, or the letter we're not using, is angle B. Our next smallest side is side AB with 12. The angle across from it, or the one we're not using, the letter we're not using, is angle C. And then our biggest side is 15, which is BC or CB, either way you want to look at it. And the angle across from it is angle A. And so now we have our answers from smallest to largest. We can say angle B, angle C, and angle A. All right, last thing we're going to talk about is how to classify the triangle by the angles, because we can't look at a triangle and just determine the angle sizes. We have to know what the angles are. And so if we know what the angles are, it's really easy. But what if we just know the side lengths? Here is the way we do this. And down here, we can see our formulas. We're going to be using a basis off the Pythagorean theorem. If we use the Pythagorean theorem, then we know for sure that it is a right triangle. If Pythagorean theorem works, it's a right triangle. And so we're going to use a version of that to figure out if it is an acute triangle, an obtuse triangle, or a right triangle. First thing we have to do is figure out if it is a triangle to begin with. So if we add our two smallest sides, we get 8. Is 8 greater than 7? Yes, so I know for sure this is a triangle. And so our biggest side is 7. And the biggest side always represents your C. So we're going to be using a version of C squared compared to A squared plus B squared. So our C, our biggest side is 7, so 7 squared compared to A squared, which is 2, or 6, it doesn't matter, the order of the A and the B. Okay, so now we have 7 squared, which is 49. We know 2 squared is 4, and 6 squared is 36. So how does 49 compare to 4 plus 36, which is 40? Well, it's greater than. And if we go down here to our little key, greater than means that it is an obtuse triangle. Okay, let's go to the next one. Take our two smallest sides, add them together. Is 7 greater than 10? No, so this is not a triangle. There is no way we can finish that one out. Okay, the next one, take our two smaller sides, 7 and 24, which gives us 31. Is 31 greater than 26? Yes, so we can continue. Remember, we're using the same formula, C squared compared to A squared plus B squared. You have to use the C squared first for the greater than less than thing to make sense. So our C is the biggest side, which is 26. And we're going to compare that to our A squared plus our B squared. So 7 squared plus 24 squared. 26 squared is 676. 7 squared is 49. 24 squared is 576. And so if we compare those two, after we add them together, we get 625 here. So we have a greater than symbol, and again, we have another obtuse triangle. Excuse me, guys, sorry. Okay, so use this key down here. If it's less than, it's an acute triangle, which makes sense because the smaller triangles are the acute ones, the less than. Greater than is obtuse. The bigger angles are always the obtuse ones, so that makes sense. Greater than obtuse, less than acute. If it ends up being equal to, we know it's a right triangle because then